Hello everyone, welcome to my JE Physics. So today we are going to see a different type of question where two capacitors are given, are charged to different potentials, as well as they are connected differently also. Positive charge on one plate or positively charged plate is connected to negatively charged plate, and they have given two switches. Okay, then what they are asking in the question, they are asking when both the switches are closed, then find the charge flown through resistor as a function of time. Okay, so why I have chosen this question, because most of my students has gone incorrect answer. So let us see, and one by one I'll explain why I have chosen this question, because this is little different from the regular question. Usually, see, in the classroom, very fundamental thing is what, when a charged capacitor, let us say Q plus Q naught and minus Q naught, is going to connect with a resistor R, then we call it as discharging of capacitor. So we know that charge on the capacitor Q naught into e power minus t by RC. So this is the regular question, but now they have a little change to what, different charge capacitors are connected. So when S1 and S2 are closed, let us see what will happen. Okay, so before going through the solution, so please give a try once and see what is the answer you are getting. Then go through the solution, then you will understand where you have done the mistake. Okay, so then if I am taking as it is, let us say, then it is plus 3CV naught and minus 3CV naught, and this is 6C and 2V naught, then it is minus 12CV naught, and this is plus 12CV naught. Okay, so if you close the switch, as soon as you close the switch, the potential difference across the capacitors should be equal, because they are in parallel. That means there will be charge distribution among the capacitors within no time. It doesn't take any time. Okay, within no time the charge will distribute on both the capacitors in such a way that the potential difference across both the capacitor has to be same, as well as they have to follow the charge conservation also. So this is completely instantaneous phenomena. Okay, so as you close the switch, then what will happen? So let us say this is the one capacitor and this is another capacitor. Both are connected to resistor R. Okay. Now let us say that this will have the Q1 charge and this will have the Q2 charge. So here minus 12 CV naught and this is plus 3 CV naught, means together these two plates will carry the minus 9 CV naught. So that's why I'm writing as minus Q1 minus Q2. So I don't know, just again it's my assumption only, plus Q1 plus Q2. Then we can write down that Q1 plus Q2 value, total charge value is equal to Q1 plus Q2 value is equal to 9 CV naught. Okay, 12 CV naught and minus 3 CV naught. So total will be plus. Okay, so on the left side plates it is negative. At the same time, as I told you, see, they will maintain the same potential difference. Otherwise, there won't be in parallel connection. See, the potential at this point is VA, potential at this point is VB. Across the first capacitor it is VA minus VB, across the second capacitor also VA minus VB. Means the distribution of charges will take place instantaneously. As soon as you close the switch, then automatically charges will distribute. So now I am finding those charges distribution, then discharging process will start. So I can write down that Q1 by C1, which is nothing but 3C, is equal to Q2 by 6C. So then I can write down 2Q1 is equal to Q2, and in the place of Q2 if I write 2Q1, it is 3Q1 is equal to 9CV naught. Then what is the Q1 value will become 3CV naught. So one charge will be 3CV naught, other charge will be 6CV naught. This is 3CV naught and this is 6CV naught. Okay, so obviously this is minus and this is also minus of similar values you will get. So first the distribution of charges happens, then discharging will start. Okay, so I'm drawing here now. So this is the one capacitor is going to connect with one more capacitor. Okay, both are going to connect to a resistor. Okay, then this is having the plus 3V naught charge and this is the plus 6CV naught charge, and this is 6C. Okay, capacitance, and this is 3C, means both will get the V naught potential difference. Okay, so both are parallel. So you can take this one as, now see, this is the scenario at time is equal to 0 as soon as you close the switch. Now there is a charge transfer from positive plate to negative plate, something like this. So there will be a discharging of first capacitor as well as second capacitor. Again, both will discharge in such a way that both will maintain the same potential difference. That's why you can take it as a single capacitor of how much? 9C with plus 9CV0 charge and minus 9CV0 charge. Okay, initially. So I'm taking as a single capacitor of connected to resistance R. Then how to find out the charge on the capacitor? We can write down the charge. It's simply CR circuit and discharging circuit. I can write down that charge as a function of time. Okay, charge as a function of time can be written as what? Q is equal to, it's not Q power, just I wrote function of time, Q naught into e power minus t by RC. This is the formula. Now write down the value. Q is equal to, Q naught means initial charge 9CV naught, e power minus t by R into C value is 9C, so it is 9RC. So this is the charge, but remember, this is not the question they are asking. They are asking what is the charge flown through resistor. So most of the people gone through this answer, C option, but which is not correct one. Okay. Now how to go for a charge passing through resistor? So to find out the charge passing through resistor, first we will go with what is the current in the resistor. Current in the resistor as a function of time. The current in the resistor is dq by dt, which is equal to 9CV0 into e power this derivative. So you will get minus 1 by 9 RC into e power minus t by 9 RC. Okay. So then current value will get V0 by R, because 9C cancelled out, minus is there, minus t by 9 RC. Okay, so actually current value we can write down minus dq by dt here, because actually charge on the capacitor decreases. If I am writing the minus, then you will get it is positive. Then current through that V0 by R into e power minus t by 9 RC will be the good expression for the current. Current continuously decreases with the time. Actually current should be something like this. This is the current with time. Actually graph is not needed, just to recollect the idea, that's it. So this is the current through resistor. Now we need to find out the charge value. Again we can integrate this part. So I can write down the current value is minus dq by dt, which is equal to V0 by R into e power minus t by 9 RC. Okay. Then dq can be written as V0 by R minus of e power minus t by 9 RC dt. Now integrate. Okay, 0 to t will be the time integration. Then charge flown through resistor is equal to V0 by R will come out, constant, and e power minus t by 9 RC. I can write down the integration value is e power minus t by 9 RC by minus 1 by 9 RC. Okay, from 0 to t. So minus V0 by R into, so minus of minus it will be positive. You can multiply with 9 RC. 9 RC will be multiplied, comes into numerator. Then if I am writing the limits, e power minus t by 9 RC minus of e power 0. So finally what is the charge passing through resistor is, R cancels out, this 9CV0 into e power 0 is 1. So I can write down that e power minus t by 9 RC minus 1. Okay, so this is the charge passing through resistor R. But you can see here 1 minus as given. So actually this is not a magnitude one. This is we wrote minus dq by dt. So as I am writing the minus here, charge value is decreasing in function. Okay, na? So that's why as charge value is decreasing in function, I got something like this. But if you find the magnitude of the charge, then you can write down that magnitude of charge is equal to 9CV0 into 1 minus e power minus t by RC, 9 RC. So where is the problem comes? Why? Because see here why we are getting the negative sign, because already we have taken the negative here. Okay, so if I am taking the simply current value is dq by dt, because let us assume like in q is increasing or decreasing, we don't know, then we would have got the perfect answer. Okay, so no need to worry much about this idea. So try to understand how we did the question.